Hello! In this section, we will discuss how to choose the propulsion elements of a drone. The propulsion elements are determined based on the type of drone you want to design. Do we want a nimble and fast drone? Or a drone with a high payload capacity? Or do we just prefer a long flight time? The propulsion system is based on motors. The motor turns the propeller, and the propeller generates thrust. Accordingly, the motor is selected. Other important factors when choosing a motor are efficiency value and kV rating. The kV rating is a value that indicates the rotational speed produced per volt by a brushless motor and is directly proportional to the drone's agility. For example, a 1000 kilovolt motor will spin at 1000 revolutions per minute when 1 volt is applied. A 500 kilovolt motor will spin at 500 revolutions per minute when 1 volt is applied. The efficiency value is expressed as the ratio of the thrust force produced to the current consumed. A motor with high efficiency provides better flight time. The drone's wheelbase, that is, the distance between two diagonal motors, is determined by the type of frame of the drone. If we are designing a square-type quadcopter, the wheelbase is the square root of 2 times the distance between two diagonal motors. The distance between two side-by-side motors is determined by the propeller diameter. As the wheelbase increases, more useful load capacity is provided. However, this also increases aerodynamic drag and reduces agility. The drone motor is selected based on the total weight value. According to the data provided in the motor's datasheet, you can find out how much thrust is generated with which propeller type, at what voltage, and with what current. Other factors to consider when selecting a drone motor are efficiency and kV values. We have mentioned these before. After selecting the motor, an AC electronic speed controller with a voltage identical to the motor's required voltage and at least twice the motor's maximum current draw is chosen. The ESC is the brain of brushed motors. We have decided on the type of unmanned aerial vehicle we will design. Accordingly, we have learned our weight. We chose our motor suitable for our agility requirement. We determined the ESC and which inch propeller to use according to the motor. Now it's time to choose the battery. The battery choice is made based on factors such as the battery's weight, voltage, capacity value, and instantaneous discharge current. The maximum instantaneous discharge current is determined to be above the total current drawn by the unmanned aerial vehicle. The battery voltage is chosen to be compatible with the motor voltage. The battery capacity is determined to be at an optimal level so that the battery weight does not negatively affect the current drawn. All right. After determining all the components of the propulsion system, we can calculate the flight time. It is calculated by dividing the battery capacity in ampere hours by the total current drawn during hover. However, since we can't use the entire battery, we use 85% of this time. Since the calculated time is in hours, we multiply it by 60 to convert it to minutes. That's how easy it is to calculate the flight time. Thank you for listening.